Hello and welcome to session 3 of the Chemistry GCSE online revision resources. Today we have to look at the components of an atom, and this table that I've put here should be very familiar to you all. The atom consists of protons, neutrons and electrons, and we normally symbolise a proton as a P, a neutron as an N, an electron as an E. The charges and masses are written down there. The easy way to remember it is that protons begins with letter P and it's positive, a positive charge +1. A neutron is neutral, therefore it's got no charge. Again, easy to remember. Neutron has the start of the word neutral in it, and that just leaves you with electrons, which must be the other one that's left, which is negative. The masses, again, are given there. The mass of a proton is 1. This is a relative mass. That doesn't mean that the proton has a mass of 1 gram or 1 kilogram or anything like that. But it does mean that the mass compared to the mass of a neutron is the same. So they've both got the same mass. So we say the mass is 1. We call that the relative mass. Finally, an electron. Now, an electron has got a very tiny mass, but sadly, you're not allowed to say it's 0. You must say it's 1/2000th of the mass of a proton or a neutron, or you can say that the mass is negligible, i.e. that it doesn't really matter. If you think about it, you need 2,000 electrons to give the mass of 1 proton or indeed 1 neutron. So if you had something which had, say, 5 electrons in it, that's 5/2000ths of the mass of a proton. So even if you've got 5, or even if you've got 100, it doesn't count towards the overall mass of an atom. Now, there are a couple of other things that you need to know for this topic. The first thing is what the definition of an isotope. So an isotope, and the definition of an isotope is an atom of an element which has a different number of neutrons. So, for example, the classic example that you're usually given is chlorine, and there are 2 types of chlorine atoms. Both of them have 17 protons, and that means when the atom is neutral, they will also have 17 electrons, because atoms have to be neutral. So they have the same number of protons and electrons, the same number of positive and negative charges. However, the 2 isotopes of chlorine, one of them has a mass of 35 and the other one has a mass of 37. Now, in the previous video, we talked about numbers of nucleons. That is the number of particles within the nucleus. So this isotope of chlorine has 35 particles in the nucleus. This isotope of chlorine has 37 particles within the nucleus. Now, we know that both of them have 17 protons. So that means that this first one has 35 minus 17, so the total number of nucleons, minus the total number of protons, which must mean it has 18 neutrons. This one, on the other hand, will have 37 minus 17, which equals 20 neutrons. So the way you find the number of neutrons is you do the mass number, the atomic mass, and you take away from it the number of neutrons, the atomic number. If you want to make a particle which is not neutral, all you have to do is change the number of electrons. Now, that makes something called an ion, and an ion is simply an atom which has either gained or lost electrons. Again, you should be relatively familiar with this because you've talked about things going to a full outer shell. This comes up in a much later video, but for the moment, all you need to know is that an atom is neutral. It has the same number of protons and neutrons, and sorry, that was wrong. The same number of protons and electrons. The number of neutrons does not affect the charge of an atom, it just affects the mass. Remember also the location of each of these things. So the protons are in the nucleus, and that's what we were talking about before. They are nucleons. Neutrons too are in the nucleus, so they too are nucleons. Electrons are in the orbit around the outside of the nucleus. And remember, you're allowed, we talked about this in the previous video, you're allowed 2 electrons on the first shell, 8 on the second shell, and 8 on the third shell as well. You can identify an element simply by the number of protons. So, for example, here with the chlorine, both of these are chlorine because the bottom number is 17. So, for example, if you had something like this and you didn't know what the element was, I'm going to give it the letter X, but you know that the bottom number is 7, then you know that this element should be nitrogen. You look it up in the periodic table. Now, nitrogen, if you look it up in the periodic table, has a bottom number of 7 and a top number of 14. If, however, the top number was 16, would you then look at that element and say, oh no, it can't be nitrogen because it hasn't got the same top number? Well, no, you couldn't do that. It is nitrogen because it has a bottom number of 7. However, what is important is that this 16 is not 14, because that's what you'd see in the periodic table. So you would then say that this is an isotope of nitrogen, an isotope of nitrogen. So you can still say it's nitrogen because the bottom number is 7, but what you can't do, what it is an isotope of nitrogen. It's not what you might call normal nitrogen. Right, thank you very much for watching this video. Make sure you go into Show My Homework and find out when your time is for teacher consultation. It will either be Thursday or Friday, depending on which band you're in. Also, make sure you go into SAM Learning and do the assigned tasks. Thank you for watching.